Forces review. So let's start by the concept of force. What is the definition of force? So force is any push or pull that you do on an object with mass. What are the units for force? Units are newtons. And we represent newtons with uppercase N. What is the formula for force? So the formula is pretty simple. That is F equals mass times acceleration. Acceleration can be sometimes the acceleration due to gravity, so 9.8 in this planet, or depending on the problem, the acceleration may be different, a different number. Okay, so what are the forces we have? So for this class, we are going to study 5 types of forces. So if there is an applied force, so applied force we represent that with FA. Applied force means when you push at something, when there is contact and you're pushing at something, basically. We also have normal force. We represent normal force with Fn. Normal force is the force present due to the contact with a surface. So if you have a box on a table, the table is the surface and that is applying a normal force over that box. If you are standing up, the floor is the surface and the floor is applying a normal force upwards to hold you. We also have weight or force due to gravity. Force due to gravity, and we represent that with Fg, or gravitational force. And if you have like the object is in motion and in contact with another surface, that is what we know as friction. And we represent that as FFR. We have one more, which is tension. Every time that you're pulling at something, like a string or cord or rope, it means you have a tension force, and we represent that as Ft. Okay. So now that you know that we have these 5 forces, we can talk about force diagrams. So force diagrams are the diagrams that help you to understand how the forces are being applied in a body. So let's do the force diagram for a box. So let's take orange. Force diagrams are also known as free body diagrams, so it's the same thing. Let's pretend you have a box right here at the top of a surface, but the surface is not horizontal. It is tilted. It has like an inclination. So the first step that you want to do is to draw a dot in the center. And then from that dot, you're going to start drawing all the arrows that represent the different forces. So the first force and the easy one to represent is weight or force due to gravity. Force due to gravity always points downwards, always towards the center of the planet. Is someone pushing at this box? No. So you start asking those questions. So you know that if no one is pushing at this box, there is not applied force. Okay, we don't say equal, we just say that it's not present. Okay, next one. Is the box in contact with any surface? Yes, and this is the surface, and the surface, as I said before, is not horizontal. So you want to draw the normal force due to that surface like perpendicular, like 90 degrees with the surface, and that will be your normal force. Is there any string present? Is like someone pulling at this box through a string? If not, that means that we don't have tension. So force of tension is not present. Is this box moving? Well, since this box is on a surface that is tilted, there is an inclination here, if there is no friction, it means that the box would actually go downward. So there should be friction present. And friction always points towards the opposite direction of motion. So if this box was moving, it will go downward, right? So that means that friction actually goes in the opposite direction. So force of friction. And at the end, you can check if you have the 5 forces. So we have 1, 2, 3, 4, and 5. So we have all the forces for this diagram right here. So you know what are the direction of the forces. Okay, so this is like a more like graphic diagram, okay? And let's do another example really quick here. So what if you have like the ceiling? This is how I represent the ceiling. There is a string right here, and there is like a pendulum right here. Okay, let's do it again. So step number 1 is actually like drawing the dot in the center, and then you start like putting all the other forces here. So the first force you want to represent is weight, or the force due to gravity. Remember, it always points towards the center of the planet or downwards. Okay, is someone pushing at this ball? No. So apply force, nothing. Is this ball in contact with a surface? No, it's not touching anything here. So normal force is not present. Is there anyone or there anything like pulling from this ball, like string or cord or rope? Yes, right here. So tension always goes in the same direction of the string. That would be force of tension. Same direction. Okay, is this ball being rubbed against something? No, so friction is not present. And then you can check just to make sure. 1, 2, 3, 4, 5. 5 forces. And that's it. Okay, this is like the graphic analysis for forces. But what if you need to do like a more mathematical analysis? So this is pretty simple. If you have, for example, a box right here, and there are 2 forces being applied. One that is 2 newtons towards the right, and another one that is also 2 newtons towards the right. Since the two forces are pointing towards the same direction, which is the right direction, how can you know the total force here? Well, you just add the forces because they are going in the same direction. Okay. Now, how about if we have the same box, but now one person is pushing towards the right with 2 newtons and another person is pushing towards the left using 3 newtons. Since they are going in opposite directions, what you are going to do is subtract. Because they go in opposite direction. So what will be the resultant force here? 3 minus 2, that will be the resultant will be 1 newton towards the left side. Okay? How about if they have a box here and one person is pulling this box towards the right with 4 newtons and this person right here is pulling the box upward at using 3 newtons. Okay, so what you can do is do an imaginary line and you connect them and you have a triangle, right? Since this has a perfect 90 degrees angle between them two. And you know how to do this. You can use the Pythagorean theorem here, and you know that the resultant force is going to be whatever your A side is to the second power plus your B side to the second power. So R equals square root of 4 to the second power plus 3 to the second power. 4 because this is one side and 3 because this is the other side. So 4 to the second power is 16, 3 to the second power is 9, 16 plus 9, that's 25, and square root of 25, that will be 5 newtons. So the resultant will be 5 newtons diagonal. Okay? Alright, that's it. That is the review for forces. Hopefully this is useful for you.